Good evening, ma'am. Good evening, everyone. I am Annapurna SK from 5th semester BTech CSC GM University, Davangere. Today we are presenting the review 2 of our project based learning. The topic name is fake news detection using NLP. So the first slide is about the recap of the previous phase. We defined our problem statement to automatically detect and classify fake news articles using NLP techniques. We studied several research papers during our literature review and found that deep learning models like LSTM perform better than traditional machine learning for fake news detection. We selected the Kaggle fake news dataset, which contains labeled real and fake data, articles from various sources and magazines. After analyzing it, we finalized LSTM as our model since it understands word sequence and context effectively. We also performed pre-processing, which included cleaning, tokenization, and lemmatization to prepare the text for training. In this phase, we focus on implementation, model training, and evaluation using matrices like accuracy, precision, and recall, and also F1 score. Now, the second slide is all about system architecture. And this is our system architecture showing the complete workflow of our project. It starts with data collection, where we use the Kaggle dataset containing real and fake news. The next step is pre-processing, where the text is cleaned, tokenized, and lemmatized so that the model can pre-process it effectively. Then we move to the LSTM model training, which is the main part. LSTM captures the word sequences and understands context. This helps it accurately identify the fake news. After training, we evaluate the model's performance using accuracy and F1 score. And finally, the system predicts whether new article is fake or real. In short, this architecture represents the entire pipeline from data collection to prediction, ensuring an accurate and automatic fake news detection process. And the further will be continued by my teammates. Thank you.
Good evening, everyone. I will be explaining about the model workflow and details. On this slide, I will be explaining about the workflow and the architecture, implementation, environment of our fake news detection model, which is based on LSTM or long short-term memory network. In this model workflow, our workflow begins with data collection. We obtain our data set from Kaggle, which contains a balanced mix of both fake, real news articles. Once the data is collected, we move on to the pre-processing. This is a crucial step because raw text often contains noise such as punctuation marks, stop words, and unnecessary symbols. We clean the text, remove the stop words, and perform lemmatization to reduce the words to their root form. For example, words like running and ran are both converted to run. And after pre-processing, we convert the clean text into word embeddings. Embeddings are further are numerical representations of words that help the model understand the semantic meaning and relationship between the words. And next, the processed data is passed on to the LSTM model, which is designed to handle sequential data. Since news articles have context that flows across sentence, LSTM helps capture that long-term dependency between words. Once the model is trained, we move on to the evaluation phase where we test its performance using metrics such as accuracy and F1 score to ensure the balanced performance on both fake and real classes. Finally, the trained model is used for prediction. It can analyze a new article and classify them as either fake or real. And moving on to the LSTM model details, our model uses the deep learning architecture based on recurrent neural network. It starts with embedding layer with which converts each word into fixed length vector. Then we use LSTM layer with 128 units to learn sequential patterns in the text. This layer is key to understanding context and improving accuracy. After the LSTM, we have dense output layer with sigmoid activation function. Sigmoid outputs a probability between 0 and 1, which we interpret as 0 for fake news and 1 for real news. For training, we use Adam Optimizer, which helps model converge faster and more efficiently. The loss function is binary cross entropy, which is ideal for two class classification tasks like this. Um, and that's it for my part. Thank you.
Good evening, everyone. I am Chandana. Today, I am here to explain about the further continuation part, that is implementation environment. We implemented our model using Python 3.12 version on the Google Colab, which provides a free cloud-based GPU environment for the deep learning. We used several key libraries like TensorFlow and Keras for building and training the neural network, Pandas and NumPy for handling the data, and pre-processing, natural language for natural language processing, and also scikit learning for evaluation metrics, and also to split the data set into training and testing, and for the pre-processing functions also. The hardware user was a standard Intel i5 CPU, and optionally we can use a GPU with at least 4 GB of VRAM for a fast training. Then moving on to the next slide, that is hyperparameters used. Here for a training, we tuned and selected the following hyperparameters. We trained the model for a 6 epochs, which means the entire data set was passed through the model 6 times. The batch size used was either a 32 or a 64, depending upon memory. Then we set the learning rate to 0.001, which ensures the stable convergence. Our embedding dimension was 128, representing the size of each word vector. Then the maximum sequence length was 300, meaning that the input sentence was padded or truncated to the 300 words to maintain the uniformity. Then moving on to the further slide, that is justification. This is a justification for what we did in this implementation. We used the several NLP pre-processing techniques to clean and prepare the news text before training. This includes tokenization, padding, which converts the text into numerical sequences that a neural network can process. The reason we choose the LSTM model is it because it effectively captures the context and the word order. Unlike traditional models that only look at the individual words, the embedding layer plays a crucial role in helping the model understanding the semantic meaning between the words. Finally, we trained and tested the model using binary cross entropy and our Adam optimizer, achieving the good accuracy and strong performance in detecting the fake news. That's all to my part. Further will be continued by my teammates.
Good evening, everyone. I am Prarthana K. Now I am going to explain the performance of our fake news detection model using standard evaluation matrices, accuracy, precision, recall, and FM score. And the accuracy um, measures how often the model gives the correct prediction, and the formula it's yeah, and accuracy we got it out of all prediction 99 percentage were correct. And next uh, precision tells how many of the items predicted as positive, for example fake news, are actually correct. Formula its precision is equal to true positive by true positive plus false positives. And here we got it 99 percentage. When the model predicted the news as a real or fake, it was correct 99 percentage of the time, showing a very few false positive. And recall shows how well the model finds all the actual positive cases. How many of the real positive did we catch? And here the model successfully identified all the true cases. It did not miss any fake or real news. And FN score, this is the harmonic mean of the precision and recall. A perfect score of 1 shows excellent balance between the two. And here the FN score is the balance between precision and recall. 2 into precision into recall divided by precision plus recall. And the next slide. Sample prediction. This presents a few example of our model classifies the news snippets. Government launches a new healthcare scheme. The model correctly identified this is a real news. And celebrity arrested for a tax evasion leaked report. The model predicts this is a fake, which is accurate based on our data setup. This example demonstrates that the model can effectively distinguish between the genuine and misleading news articles in practical scenario. Next will be continued by my team member.
Good evening, everyone. I am Priyanka. Now I am explaining about the challenge faced. While developing a fake news detection model, we encountered a few major challenges. Dataset imbalance. The dataset had more fake news samples than real news, which could bias the model. To handle this, we used class weighting, giving more importance to the minority like real news class during training. Next, overfitting. The model performs very well on the training data but poorly on validation data is a sign of overfitting. We fixed this by applying dropout layer and early stopper to prevent the model from memorizing the data. Next, text cleaning requirement multiple iterations. Pre-processing the text was tricky because of noisy data like unwanted symbols, URLs, and inconsistent cases. It requires multiple iteration of cleaning and testing to get better model accuracy. Next, conclusion. Next slide. Conclusion. After resolving these challenges, we reached the final output of the project. Model effectiveness. Our LSTM based model accurately detect fake news, providing that deep learning can effectively handle text classification problems. Important of NLP pre-processing. We observed that pre-processing steps like tokenization, stop word removal, and lemmatization greatly improved performance. Next reference. These includes all the research papers, articles, and dataset we referred to while building our model. Thank you.
ಎಲ್ಲರೂ ಮಾಡಿದ್ರೇನಪ್ಪ everybody completed your presentation. I think Chandana, Prarthana, Priyanka, Anna. Okay, now show me the demonstration. Hello,
Yes, ma'am.
are you showing the demonstration?
Yes.
Yes.
Meanwhile, let me ask the question. What do you mean by lemmatization? What is the role of your lemmatization in your design, in your design model?
Lemmatization is
Continue.
reducing a word to its base or root form while keeping its actual meaning in context.
Okay, does it playing any vital role in your model design? Suppose if you remove the
Yes, ma'am.
lemmatization part, what is the
Yes, ma'am.
effect on the model?
Ma'am, while using the lemmatization, the process of converting a word to its dictionary form, we will get to know, like, for example, while there will be a running, we will convert it to the run, so that it will uses a linguistic language knowledge, like a part of speech tagging, and how exactly that words combine, and it will follow that semantic manner of the particular sentence by after removing all the those lemmatizing words, so that in the word can appear multiple times, like run, ran, run, so that for a particular word there will be many verbal forms. So if we won't lemmatize it, the model will treat them as a different word, they like increasing the vocabulary size and reducing the learning efficiency. So if we convert them to its normal form, so the efficiency will be increased and complexity will be decreased.
Oh, okay. Now, can you differentiate between the parameters and hyperparameters?
Yes, ma'am.
Tell me.
Parameters
Here,
mean
ma'am,
they learn from the training data. It is adjusted during the model training. For example, weights in neural network or coefficients in the linear regression. And hyperparameters means set before the learning the model, ma'am. Not learning from the data. Example, learning rate or the number of hidden layers or number of epochs. In short, parameters are learned from data and hyperparameters are set before the training, ma'am.
Okay, any other answers for this question?
Parameters means what the model learns by itself, but the hyperparameters are which we give that control the model how exactly it will run. That we will define, like how many units, like which optimizer we are going to use, and how many number of epochs, and what how much of time we are giving the model to train. Hyperparameters will be specified by the external setting which we choose before training the model.
Any other answers?
Parameters are internal values learned automatically by the model during training. Like examples are weights and biases in neural network. For in linear regression, slope and intercept. And in hyperparameter is external setting you choose manually before training the model. No? Examples are learning rate and number of epochs, batch size, etc.
Okay. All different answers. Okay, fine. Good. Good attempt. Next is what see you have used LSTM, right? What made you to use
Yes, ma'am.
LSTM
Yes,
only?
ma'am.
Why can't it be any other things?
Ma'am, as in our first review, you asked about like why you are using, like why not buy LSTM.
Hmm?
Uh, yeah, we are using LSTM because some news here, especially we are using the data set is of articles and politic related data. News articles are often made of a sequence of words, meaning depends on a word order. LSTM is a type of recurrent neural network designed to remember the context and sequence. Which it have a three cells, that is input cell, forgot cell, and
Outputs.
store cell, which like it will take the input and it will monetize that which one it has to keep and which one it has to delete, so that it will learn the semantic, it will remember the semantic manner of that particular text. For example, the president denies the rumor, or the rumor denies the president, or the same words, but the order changes, meaning that the LSTM model understand that and keep it in its memory cell, so that whenever we are giving that particular news, irrespective of the order change, it will predict the same a value which is real or a fake, which is defined during the training.
Okay, you said you mentioned the evaluation metrics. Accuracy is
Yes, ma'am.
99%, recall if one score. Don't you think there are various models which will also provide the same values for the metrics? Okay, and what I'm expecting is what is the novelty in your model compared to rest of the model, which also gives 99% of accuracy.
Ma'am, most of the fake news detection using DL, many of them used by LSTM model, which will also give us the same accuracy, that is 99. But complexity increases, and uh, Even some other did this using a navy bias and logistic regression, and even they mixed two different types of algorithms, that is machine learning and DL, which will increase the complexity. So that's why we use only LSTM model. We haven't combined two other algorithms in same.
Any other answers apart from this? Okay. Have you presented your idea, this PBL concept, anywhere in paper, journals, or you could have done it in the international conference or the national conference conducted in your own university?
Yes, ma'am. Ma'am, you asked what exactly the novelty of this. Ma'am, here even for embedding also we used word to vector embedding, ma'am. Some other used other embedding which they want. Here we used word to vector, and we removed like in our data set we have many data which is often don't know the publisher, or some of the tags are missing, and some of the information, if we have a news, then we don't have a description of even that data also we considered, like giving those which don't have the value. We gave a value like unknown, or we mentioned some of the different values for it, and to follow the sequence, some of the missing values also we considered giving the same values which like some of the values are missing. For if publisher is missing, we gave a publisher like unknown publisher, like that. For we considered all the data which is also missing by manipulating it to unknown publisher, and we used word to vector embedding to capture the semantic meaning.
Okay, and the next question which I asked, did you present your
Yes,
concept
ma'am.
somewhere?
Yes, ma'am.
Where?
uh, we thought of like ma'am, only we did trained like predicting it only, like what I am thinking is we can make it as a like website where where a particular person can check whether particular news is real or a fake by deploying it.
Hmm. What I'm asking is, have you
Yes, ma'am.
presented your concept or the model in any of the
Yes, ma'am.
journals or in any of the conferences?
No, ma'am.
No, ma'am.
We have
Well,
no, ma'am.
if you feel that if your model is good and you have the novelty, you could have presented and taken authentication for it, right? At least you could
Yes,
have done
ma'am.
it in your in-house conferences. You could have done it, right?
Yes, ma'am.
What made you to stop?
We haven't thought about it, ma'am.
What? You can't?
We didn't
Repeat?
think in that level, ma'am.
Okay. You're unaware of it. But you
No,
people
ma'am.
went to hackathon and all, right? Earlier.
Yes, ma'am.
Then you have exposure and you have awareness, right? Okay. Okay. Now you can you demonstrate it?
You gave us a two like two sentences or two news to predict, and I have sent those snaps in the WhatsApp group, ma'am. That is PBL group.
I've seen it.
Yes, ma'am.
I've seen it and
Ma'am,
tell me. And
ma'am,
did
the
you
sentence.
implement? I told you people real news and fake news that you have implemented.
Yes, ma'am. That one I added, ma'am. It will show like a wrong mark with the fake news, or with what the message I have given.
Let me I have seen that 1 and 0, but what I asked was whether you people. 1 second, let me check that. Yeah. Okay. Okay. So that is what you are expecting. So now will you demonstrate what you have run? Can you show me that in your PC?
Ma'am, if I run it, it will take like lot of time. For each epoch, we need 1 hour, ma'am.
I know that. Okay, anyway, I've seen offline. Fine. Okay. Do one thing, you mail the video as well as the documentation. Okay. Put me CC.
Yes, ma'am.
Okay. Well,
Yes,
okay
ma'am.
then. We'll conclude.
Yes, ma'am.
Okay.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.